Alright guys, this is take 2 on derivative of an inverse function. My mistakes are driving me crazy. So, let's start again. I'm going to have a blooper reel. Alright, here we go. Yesterday we looked at functions and their inverses. Here's a function, square root of 3x minus 5. If I want to find the inverse, I'm swapping out the x with the y and solving for y. And I get x squared is equal to 3y minus 5. Solve for y and I get x squared plus 5 all over 3 is equal to y. I'm going to rewrite in function notation. Inverse f of x is equal to 1/3 x squared plus 5/3. And we looked at a couple of points on each of the equations, each of the functions. If I look at f and I plug in a 2, I get a y value of 1. I also plugged in an x value of 10, and I get a y value of 5. On the inverse function, we know the property that the domain of the function now becomes the range of the inverse function, and the range of the function now becomes the domain of the inverse function. So let's use those points that I chose. 1 will now be my x value, and I plug into my inverse function. 1/3 plus 5/3 is 6/3, so I get 2, so that checks. If I plug in a 5 in my inverse function, I get 25 times 1/3 plus 5/3 is 30/3, which is 10. So that checks. The actual verification, as you know, is the composite of the two. So it's f of inverse f of x, and I get x. Then I look the other way around. Inverse f of x equals x. So that's your analytical verification. Alright, time to start talking derivatives. So I have my function and my inverse, and I just chose one of those 2 points for us to focus on. First, I'm going to find the derivative of my function, and I get 1/2 times 3x minus 5 to the negative 1/2 times 3. My rewrite looks like this. 3 all over 2 times the square root of 3x minus 5. The derivative of the inverse notation starts to get a little funky here. So inverse f prime of x equals 2/3 x. Alright, let's look at the derivative at this point. F prime of 10. F prime of 10 is equal to 3 over 30 minus 5 is 25. Square root of 25 is 5 times 2. I get 3 over 10. Now let's look at that point, 5, 10, and the derivative at 5. What do you think is going to happen? Well, you probably already know since you watched my blooper video. So I'm going to go 5 times 2, and I get 10/3. Woohoo! Look what I did. 10/3. All right, and they're reciprocals of each other. All right, let's move on. All right, so the shortcut looks like this. The derivative of an inverse function is equal to 1 over f prime of f inverse of x. So, let's verify. F inverse prime of 5 is equal to 1 over f prime of inverse f of 5. Well, I recall that inverse f of 5 is equal to 10. So I've got 1 over f prime of 10. And I'm going to recall that f prime of 10 was equal to 3/10. So inverse f prime of 5 is equal to 10/3. So this is going to come in really handy when, I have a function that it may not be so easy to find the inverse. And I can use this shortcut so much more efficiently. All right, next video will be the specific answer, problem 71 from page 349.